We had developed 3 forms of the trajectory equation when we launched a projectile from the ground. Would these equations be applicable when the projectile is launched from the top of a tower? Here are the 3 forms again. The first form is a raw or a basic form. The second was just a manipulation of the first form to make it easier to remember. And the third form again is a manipulated form to make it more effective to use when the launch angle has to be computed, as we would have just a single variable in tan of theta. Now we would have to check if these are valid for a launch not from the ground but from a tower higher than the ground. Let's begin with the first one. The trajectory equation gives us the height as a function of the x displacement. So y is the height above the launch point, not from the ground, and x is the displacement from the launch point along the x-axis. Also, as long as y is above the reference line, it would be positive. So here y would be positive for this value of x. Let's check y at other values of x. Here again y would be positive. But the moment x goes past b, we would get a negative value of y, as for this value of x, y would be below the reference line. All these displacements are from the horizontal reference line which passes through the launch point. This trajectory equation is now valid for a projectile motion from a tower, just like it is valid when the projectile is launched from the ground. It is valid for this section A to B and continues to be valid between B and C. Only remember that the y displacement is from the reference line and not from the ground. Now let's move to the next form of the trajectory equation. This is a form that is easier to remember, but be very careful with this form. The range RAB is not the full range AD, but only the portion from A to B. So only to the same horizontal level that the projectile was launched from. And this we can obtain using the range formula as if the projectile was launched from the ground, which is V0 squared sine 2 theta over g. So literally, in computing the range, we treat the part from A to B as if the projectile was launched from the ground at A and it got back to the ground at B. Now this is the part which you had to be very careful about in applying the formula when the launch is from a tower. If you find this confusing, you could simply stick to the first form and try to remember that. All these can be easily derived from the basic principles by applying the equations of motion independently along each axis. It is just that when you're answering competitive exams, you may not want to end up spending precious time on derivations. Now let's move on to the next form, or the third form. This form is used when we have to find the angle of launch. Here we have a single variable in tan of theta. We would have to solve the quadratic in tan of theta, and finally we would get to theta. This is also a perfectly valid trajectory equation for the launch from a tower, and is valid from the portion A to B, and is also valid from B to C. And just like the first form of the equation, when x lies between A and B, y would be positive as it would be above the reference line. And when x moves beyond B, then y would be negative as it would lie below the reference line. You always have to bear in mind that these y displacements are from the reference line which passes through the launch point. The displacement from the ground would be the tower height, which is h, minus y. So we have seen in this lesson that the trajectory equations are perfectly valid for a launch from the tower. Just be careful in understanding the range in the second equation. Also keep in mind that the y displacement is from the top of a tower or from the launch point, not from the ground. The first and third forms of the trajectory equations are valid when the projectile is launched from a tower. You have to remember, though, that the y displacement is with reference to the horizontal line through the launch point and not from the ground. The second form of the trajectory equation is also valid provided you remember that the range is not the full range of the projectile, but up to the point where the projectile comes back to the same horizontal level that it was launched from.